Hello, good afternoon, ladies and gentlemen. Thank you for coming despite of the very good weather outside and hear my talk about the challenges of historical material and an overview of the technical tools that we have in IMPACT. As suggested, as you can see by the title, my talk will have two parts. One is the challenges and the second part is the technical solution, about the technical solutions. I apologize in advance for those of you who already know very good about the challenges and the problems and want to know now what are the solutions. So I will go quickly through the first slides, and I think also other speakers today that I didn't have seen today, but they might have talked already about the problems. So I will try to come quickly about and talk about the solutions. I will also add a few words later to my primary work package, which is the Interoperability work package, which tries to get all the tools working together. I'm a software developer and researcher at the Austrian National Library. My name is Sven S. So what are the challenges of historical materials? We have mainly sometimes warped book pages. For books, mainly warped book pages because of the thick spines. We have skewed and distorted scans, curved text lines, and also creased pages due to the humidity of the paper. Annoying color blots, different print intensities. We have shine through and bleed through on the pages. Gothic fonts, mainly in German papers. Handwritten annotations, complex layouts, historical languages, and so on. So that are mainly the challenges that we find in many of the materials in the libraries. I will come to some of those in detail now. So we at the Austrian National Library, we have many tables in our print material, and this is one example of a table where we have curved cell borders. That is difficult because the OCR engine is supposed to recognize also cell borders. This is most important if we have to deal with numbers and statistics in the table. Then it's important that the numbers are represented correctly and in the correct cell and so on. Extreme warping for thick spines. This is an example which has also Gothic fonts, annotations, and it's quite difficult in this case to recognize the chapter number, for example, which has to be separated by other numbers on the top. On the bottom, you have to decide what is chapter number, what is page number, and so on. This is an example of warpage due to humidity. We have also distorted page. We have page borders, crinkles, dots, and blots, and also the page number has to be separated from chapter number, which is on the bottom of the page. We have complex layout. In this case, it's extremely difficult to identify the reading order of the page, because you see on the bottom you see a thick line which separates the two parts of the page, which are completely separated. The second one is another article, and if we really would like to reestablish the reading order, we would have to recognize that the thick line separates two different articles. And also, you can see that the columns are not like in modern newspapers really with a wide distance separated, but there is a line, and the text is very close to the line. And normally, this is quite a good challenge to the OCR engines to recognize these separate columns in layout detection. Here we have a skewed image with a bleed through from the other side of the page. Page number has to be recognized, and we have the Gothic font as main challenges. This is also Gothic font warping. We have page borders that have to be removed. We have curved text lines that ideally should be straight after image enhancement, and we have page and chapter numbers. And now we'll come to the part who will solve the problem in IMPACT. We have quite a big consortium of partners, mainly libraries, 2 industry partners, and 13 universities and research centers. This consortium has now recently been extended I thought it was in my head, but... in italic, you can see the new partners which have joined the consortium recently. And I will come now to the solution and show you two perspectives. One is how the different partners contribute to the technical solutions, and later I will show a bit what would be the ideal logical order of typical processing in a digitization workflow, where you can see where the different tools are typically placed. I will start above with Abby. Abby is developing OCR and text recognition software. You have heard already a presentation, I think. And Abby does contribute mainly in two parts, which is one to improve Gothic font recognition in old fonts, old books, and in the binarization and color reduction of the images. So one part is image enhancement, and the second part is really improve the core process, optical character recognition. Then we have the Dutch Institute for Lexicology. They provide us with tools for lexicon building, and these tools are used to create lexicons that can be used then, for example, with the Abby OCR engine. The main work here is to make sure that between Abby and the lexicons we have a clear interface, how they should work together, so how the lexicon, for example, should look like, that they can be used with the Abby OCR engine. And finally, also the Dutch Institute for Lexicology creates historical lexicons using their own tools for lexicon building. We have then the IBM Research Labs Haifa. They develop an adaptive OCR which is integrated into a collaborative correction system. The idea behind this is that when we have OCR errors that we cannot correct without human intervention, we have a complete system there where users can collaborate, they can log in, and on different modic they can correct words, characters on a page level as well. And the idea is that all this information that is gained from such a working session is fed back into the OCR recognition process, so that the work the result of the work goes back into the recognition process. That's the main idea behind this. We have the University of Innsbruck, the Digitization and Digital Preservation Department. They develop a software framework which is called Functional Extension Parser, which mainly is adding additional information to the OCR result. For example, layout, for the layout detection and detecting semantical units on a page. Take, for example, the page number. They develop a system which enables you to identify what is the page number on a page, and how the page borders look like, and so on. This is the functional extension parser. And we have a prototype which is developed at University of Innsbruck, which is the inventory extraction tool. Göttingen State and University Library is creating a named entities repository. This can be seen as a database where named entities are located and can be used dictionary-like in the OCR recognition. So you will also take named entities that might be present in your material of a certain period of time and use it as a dictionary to improve recognition. They also develop evaluation tools which mainly make use of ground truth data. That means corrected OCR results, which can then be compared to the actual results that are given back from the OCR recognition process, and you compare the ground truth data against the actual results and see how you can improve, how this actual workflow improves your recognition process. We have the University of Munich, which is working on linguistic post-correction. There we work also with the OCR results, mainly with the text, and make analysis of the text and the different and mainly of the OCR errors that occur in texts. And based on this analysis, you can decide whether a word or a token that has been recognized should be replaced or not. That's not so easy, because you can have false friends, and so you can make false replacements. And the main work is behind this is to recognize really the real faults and real errors and to replace them by the correct tokens. Salford University is working on, in the image enhancement part, on geometric correction. That is, for example, removing page distortion, page skew, for example, correct this. And they also make text line and word segmentation. They develop also a prototype, which is the type-written OCR, and work on evaluation tools, which also are able to compare ground truth data against corrected results. The special thing there is that they also work with ground truth data of layout segmentation, so that tools can be the results of the layout detection can be compared to ground truth data of the page segmentation. Then we have the National Research Center Demokritos in Athens. They develop different kinds of tools, all in the category of image enhancement tools, which is border detection and removal, geometric detection. They also make geometric correction related to text lines, and make character segmentation, and develop also a prototype, which is word spotting. I will come now to the other perspective, which gives a bit the logical order in a typical workflow, where the pre-processing steps, so image enhancement, are placed before the core process, which is text recognition OCR, and later you have the post steps after the OCR, which is post-correction, evaluation, structure analysis, and so on. So border removal, geometric correction, binarization are all image enhancement tools where you try to improve the image before you hand it over to the OCR. Segmentation is then really working with the binarized image and tries on the rough level to make block segmentation, so identify columns, identify images and tables, and hand this result over to the text line and word segmentation. So text lines is clearly the recognition of the text lines. Then you have to identify different words. And finally, you can hand over this result to the character segmentation, which then identifies the single characters. The difficulty is, or why do you need image enhancement here if you have, for example, curved text lines? Line segmentation gives really bad results. So it's very important to have straight text lines before handing it over to the segmentation process. Otherwise, the OCR engines usually get confused if they do not have integrated algorithms that solve this problem. So we can now hand this over to the OCR. In IMPACT, we have two different approaches. One is the adaptive OCR developed by IBM, and the other one is our commercial partner ABBY, which is developing the FineReader and improving the FineReader 10, the new version which will have all the benefits from the IMPACT project integrated. And we cannot clearly separate it here because ABBY has an internal binarization, for example. What you can do here is combine tools and see whether the binarization of ABBY is better than other solutions that you have on your own. In this OCR process, you are using the tools, you are using the lexicons that you can get from the tools for lexicon building, and you can make use of the named entities repository and feed it into your OCR engine. Later, if we have the result, we can apply linguistic text and error analysis. We can do a linguistic post-correction. This, in IMPACT, we are mainly concentrating on the automatic post-correction, but there are also approaches of creating a working session where you decide what is a good token to replace OCR errors. And as I already said, it's not so easy to decide whether you have an OCR error. You need many statistical information from from corpus material normally that gives you information on where might be OCR errors and what is a false friend, so a suggestion that would lead to an OCR, to an error in the replacement. We come then to the evaluation. I also already said that we have ground truth material of different types. So the text ground truth material, which is the corrected OCR result. And we have the layout, the layout ground truth, where you can compare the segmentation of OCR engines against the ground truth, so the ideal segmentation that should take place. After you have the results, you can use the functional Lexicons browser to enrich the results with additional information. For example, with information concerning the semantical units present in a page. So that might be a page number, a header, and you can recognize the borders. That's very important if you want to create ebooks, for example, from the material. Then you have to make sure that the page borders are correctly placed. And you can make use of the page numbers in order to create the logical order of the pages, make analysis if the process worked okay, so if the whole digitization process of the book is fine, and so on. We have then a few experimental tools, which are the typewritten OCR, word spotting, which is mainly for creating automatic indexes and finding the most important words in a text. And we have the inventory extraction, which is a completely new approach, which takes a new mathematical method in order to classify characters, also developed at the University of Innsbruck. This is just a quick example of what is border removal. It removes the border, simply. And the Abby engine does it as well, so you can compare there which gives better results. This is an example of geometric dewarping. So the difference is here that this kind of dewarping is caused by the scanning process itself. So it's a regular distortion, which can be where one mathematical method can be applied to get the straight picture. And as I already said, it's important to have these tools in order to have straight text lines and to get the text line segmentation working correctly. This is another example of geometric deskewing. The challenge here is that you have a crisped paper and you have to really line by line correct the geometry and to get the straight lines on the right side. Many of these approaches are still very experimental, so we don't get solutions to scale up to millions of pages, but we already have results for some of the pages, and we have now to work on improving it in the way that it works for millions of pages as well, and that it is appropriate for mass digitization. This example is the binarization. In IMPACT, there are binarization tools developed. The challenge here is to separate the front layer, which is the text, from everything else, which is the background noise, colors, shine through from the other side of the page, and so on. And to separate this and to get a clear picture of what has to be recognized by the OCR engine is the challenge. One interesting thing is to get modularized workflows where you can compare the results against each other. So you can take the binarization developed in IMPACT, for example. On the other hand, you take a binarization from Octopus, if you know this open source OCR engine. Not the engine, the OCR software, which also has a binarization component, and then you compare it to the Abby binarization, and you later decide which one gives the best results on your material. As far as the historical lexicons are concerned, we have mainly, for now, German, Dutch, English, French, Spanish, Polish, Bulgarian, and Czech available, but maybe this will be extended later on. as I said, we have the tools for lexicon building, and the challenge here is to get the interfacing work with the ABI-defined reader engine. ABI provides us with the information how a dictionary should look like, then we can use it. But the procedural information is disclosed, so that means that we do not know exactly what happens in the OCR engine with the dictionaries. We can only see, let's say, for example, we have a mixed language page where we have German and Czech, and then we want to know which dictionaries give the best results. The only thing we can do is to fix on the results. We cannot analyze what ABI really does with the dictionaries, but we can only focus on which dictionary or which combination of dictionaries gives the best results. So the named entities repository is built partly also from really books that are named entity repositories in paper form, and we create out of that collaborative named entities registry where people can log in and correct it, and also give categories. For example, what is a city, what is a country, what is a person, and so on. And with this registry, we can use a registry that is or a part of the registry that is focused on the material and improve OCR by that way. The linguistic post-correction does an analysis of the text. It tries to find out which tokens are correctly recognized, which tokens are supposed to be OCR errors. Then we have here suggestions, the different colors. I don't want to go into detail, but the different colors indicate that some of the tokens come from the hypothetical dictionary. Hypothetical dictionary means that if you have, for example, in German, we have the case that a word like Werte is W-E-R-T-E-E, which can also be written with H after the T in the old form. And then there is a rule which says T can be TH. And in this case, this creates a hypothesis, which can be derived from the hypothetical dictionary. And then it says, the hypothetical dictionary says that this could be an old word form in this case, or it is really available in another dictionary, then it is also shown here. So linguistic post-correction should work automatically if we know which of the replacement candidates are the correct ones. I already said a few words about the collaborative correction system, which is a complete system built by IBM, where in this case, for example, you can see a small screenshot from an older version where we have classification of characters and can decide which of the characters are recognized correctly and which ones not. And this should happen on the book level, so that for one book you could do this classification, so that the engine in principle is trained by this way to recognize characters correctly. And we can then proceed to the next modus, which is the word level correction, where you can manually correct words. Also, the information gained from this is feedback to the OCR engine. And we have the page level, where the text lines are shown and the words are shown and so on. Different levels where we can work manually to correct OCR. This tool is intended to produce ground truth material, where you take the results from the OCR engine and you can correct it and use these results, for example, to improve your own OCR process. The functional extension parser helps us to detect borders, print space, page numbers, chapter numbers, and so on, and to identify them on a page. So you can enrich your OCR results with semantical information. That's the purpose of this tool. Word spotting, as I said, I do not know very much about it, but it's a technique for indexing historical documents automatically. So to find the important words in the text and help to identify it and create an index out of it. So about interoperability means in our interoperability framework mainly the use of different XML standards for information interchange. The interoperability framework that we've built is based on web services, so messages between software components are interchanged by XML documents. And so the standard of this is XML, but the results that we get from ABBY are ABBY XML. We are using METS Alto as the most widely used standard to express page structures and character positions. We have an additional format, which is the Alto X standard developed by IBM, which improved the standard a bit and made a suggestion to the standardization committee in order to add additional information that is required for mainly for the IBM software at the moment, but they have to decide whether it is sensible to make it as a standard. We have the page XML, which is an embracing standard, which tries to combine all the different XML standards that we have and make an embracing standard out of it to get really from the intellectual entity level, the book, down to the page, to the character level, and have it all in one single page XML document. Some of us are also working with TEI, the text encoding initiative, but that's only one smaller part. To give you an idea of how we approach modularization, this is an example where we have a ground truth plain text file, so the corrected text, and on the other side we have the book newspaper page image, where we build a workflow with our software modules, where we remove the border, de-skewing, de-warping, binarization, so different image enhancement steps. We pass them over to two different OCR engines. One is the Tesseract OCR, which is part of the Octopus open source OCR, and on the other hand, the ABBY OCR engine. We can then compare these results with an evaluation tool, which compares then what is the accuracy of the one engine, what is the accuracy of the other engine on a word and on a character level, and you can decide and make experiments on your material and decide which one gives the better results. So the idea behind this is that you develop concurrent workflows and you compare then which is appropriate for your material. Furthermore, the idea is to create a community out of this to enable people to develop workflows on their own and compare them, discuss them, share them, and so on. More information can be found on the website of the IMPACT project. Thank you very much.